Venn diagram. Well, students, let us now learn to draw diagrams and figures. Study of sets has been made very interesting with the help of diagrams. This idea was used and developed by a British logician, John Venn. Let us draw a Venn diagram to represent set P, which is equal to 1, 3, 5, 7, 9, 11. To represent set P, we first draw a closed figure. The closed figure can be a circle, a rectangle, a triangle, or any irregular figure. The name of the set, that is P, is written outside the figure, and the elements are represented by dots or points inside the figure. Hence, 1 is represented by a point, 2 by another, and so on. Such diagrams are called Venn diagrams. Now, students, let us proceed further by understanding different types of sets. Types of sets: empty set or null set. Let us consider set F, which contains elements y, where y is a point of intersection of two parallel lines. To begin, students, we define the condition which has to be satisfied by element y to belong to set F. The condition is it has to be a point of intersection of two parallel lines. Now, do parallel lines intersect? Definitely not. Parallel lines are non-intersecting lines. Hence, there can never be a point where parallel lines intersect. Hence, no point will satisfy the given condition. So there will be no element that will be presented in set F. Such a set is called an empty set or null set. It is represented by writing set F is equal to null set or by the symbol 0 with a vertical line on it. It can also be represented by two curly brackets with no elements written within the brackets. Let us consider set G, which has element Z, such that Z is a natural number and is greater than 3 and less than 4. Now, students, which are the conditions to be satisfied by Z to belong to set G? The first condition is Z is a natural number. The second condition is it is greater than 3 and less than 4. Now, students, surely there is no number which is natural and lies between 3 and 4. Hence, no element satisfies the conditions. We call it a null set and write set G is equal to null as in the previous example. Singleton set. Let us take set A, which has an element 2. Set A has one element. Such a set is called a singleton set. Finite set and infinite set. Let's examine set B, which has elements 1, 2, 3, 4, 5, 6. There are 6 elements in set B. Hence, set B has elements which are within the limits of counting. We can easily count and say that set B has 6 elements. Such a set is called a finite set. Let us take an example of set D, which has element y, such that y is 3 raised to the power of n, where n is a natural number. On examining, we notice the first condition to be satisfied is y is equal to nth power of 3. The second condition is that n is a natural number represented by capital N. Now, students, if we write down the natural numbers, we will never reach the finishing line. We will begin with 1, then 2, 3, 4, and it can go on to infinity. Hence, 3 to the power of n will be 3 raised to 1, 3 raised to 2, 3 raised to 3, 3 raised to 4, and so on. We can keep on writing the powers of n to infinity. So students, set D will contain elements which are beyond the limits of counting. The numbers of elements are infinite. Such sets are called infinite sets. How to write infinite set in the listing method? In the listing method, we write set D is equal to open with a curly bracket followed by 3 raised to 1, 3 raised to 2, 3 raised to 3, 3 raised to 4, and put dots to represent the countless elements. We then close with a curly bracket. Note that an empty set is a finite set. The sets of natural numbers, whole numbers, integers, rational numbers, and real numbers are finite sets. Subset. Friends, we will now understand the meaning of subsets. The subset is denoted as, this sign denotes proper subset. Now, we will turn the sign of proper subset by 180 degrees and we get a new sign whose meaning is superset. We put a small line below proper subset and this new sign denotes subset. We now put a vertical line on the sign of subset, which means it is not a subset. Hence, students, we have now understood the different signs that denote subset, proper subset, and superset. Now, students, let us use the signs to understand the relationship between set P, which contains elements B and A, and set Q, which contains elements A, B, C. We notice that every element of set P is an element of set Q. Therefore, P is a subset of Q, and we write it as shown using the proper sign. In set P and set Q, we also notice that C belongs to Q, but C does not belong to set P. Hence, P is a subset of Q, but Q contains at least one element which is not in the set P. Then set P is proper subset of set Q. It is denoted by using the sign of proper subset. Now here Q is also called the superset of P, which is written with the sign of the superset. Now students, let us consider another set which contains alphabets A, B, C, D, E, F. Let us denote this set as U. We quickly notice that set P is a proper subset of U and set Q is also a proper subset of U. Hence, set U here becomes a universal set with respect to set P and set Q. Hence, a suitable non-empty set of which all the sets under consideration are the subset of that set is called universal set. It is denoted by U. A universal set is generally represented by a rectangle. Now, we have first to remember how a set is related to itself. Every set is a subset of itself. That is, set P is a subset of set P. Similarly, empty set is a subset of every set. Since we are well conversant with subsets and universal set, let us solve more examples to consolidate the same. Exercise 1.3. Question 1. Set A contains all residents in Mumbai. Set B contains all residents in Bhopal. Set C contains all residents in Maharashtra. Set D contains all residents in India. Set E has all residents in Madhya Pradesh. We have to find the 1. Subset relation between sets A and C. 2. Subset relation between sets E and D. 3. Which set can be chosen as the universal set? Answer. Let us examine set A and set C. Since Mumbai is a part of Maharashtra, all residents of Mumbai naturally are residents in Maharashtra. Hence, set A is a subset of C. Now students, there will be some residents staying outside Mumbai who are residents in Maharashtra. Hence, there are some elements which belong to Maharashtra but not to Mumbai. Hence, will set A be a proper subset of C? Of course, yes. So we write it as proper subset. Similarly, set B is a proper subset of set E. Now, which set is the universal set with respect to A, B, C and E? Definitely set D, which contains all the residents in India. Since set A, set C, set B and set E are proper subsets of set D, D is a universal set. Question 2. Draw a Venn diagram showing subset relations of the following sets. Set A, which has elements 2 and 4. Set B has element x, such that x is nth power of 2, where n is a natural number less than 5. Set C has element x, such that x is an even number less than or equal to 16. Answer. Well, students, now let us draw a Venn diagram to show subset relationship of set A, B, C. Now, the first step, students, is to write the elements of each set A, set B and set C in listing method. Set A is already in the listing form. Let's write the element of set B in the listing method. The elements are 2, 4, 8, 16. Now let us write the elements of set C in the listing method. The elements are 2, 4, 6, 8, 10, 12, 14, 16. Let us examine the elements of set A, set B and set C. We notice that elements of set A, that is 2 and 4, are present in set B. Therefore, set A is a proper subset of set B. Similarly, set A is a proper subset of set C. It is also very clear that elements of set B, that is 2, 4, 8, 16, are present in set C. Hence, set B is a proper subset of set C. Now, since set A is proper subset of set C and set B is also a proper subset of set C, we can call set C the universal set with respect to set A and B. Hence, students, we represent set C with a rectangle, then represent the elements of set C by a dot. We then appropriately draw circles or any other shape to include the sets A and B. Question 3. Prove that if set A is proper subset of set B and set B is proper subset of set C, then set A is also a proper subset of C. Answer. Now students, let us consider an element x which belongs to set A. Now since set A is a subset of set B, then x also belongs to set B. Similarly, since set B is a subset of set C, then x also belongs to set C. Hence, we can say that every element of set A is an element of set C. Therefore, set A is subset of set C.